collaboration. The conference is organizing, and my paper is tomorrow on this one. There, so I am going to say this topic, and I have been working on this topic 2-3 months only. That how the IoT can be applied in the manufacturing processes, especially in assembly line processes. So our lesson objective is that we have to consider a design approach using CNN based machine vision of the machine objects, assembly functions and operations for optimizing the production. So now let us first understand what is the meaning of now new terminology which is known as a Industry 4.0. Industry 4.0 is a manufacturing technology which involves machine vision. Machine vision means visualizing the machine parts, visualizing the operations of the machines. That's either by the robot will visualize, or human being, or some software will visualize, or some camera will visualize it autonomously, and so on. So machine vision, Industry 4.0 involve industrial IoT. Industry 4.0 involve artificial intelligence and use of artificial neural network, augmented reality, robots and cobots and digital twins. And now cobot means a pair of machine worker and robot, both of them they are working simultaneously, or we have got two robots, both the robots they are collaborating with each other, just like machine operator they collaborate in the industry operations. Then we are working with the digital twins. Digital twin means that human beings will also work digitally. That is, whatever they will say, it will be sent digitally. Whatever instruction they want to give, it will also be digitally, and to the robot or vice versa. So digital twin means that the two persons, two robots, one robot, one person, both are talking to each other only in the digital terms there. And autonomous systems. So these are the different elements in Industry 4.0 which are nowadays being used. Industry 4.0 deploys advanced manufacturing techniques and new manufacturing concepts by digitizing operations there, and all operations and functions they are digitized. I will give you the two references. These two references, one is the Siemens. Siemens, what the Siemens is doing and what Siemens has done, that I will tell you later on in one of my slides. And Advantage Industrial IoT Systems and Devices, it is another company. So in 2020 they have developed something very new, okay, and very new. It is being deployed in advanced manufacturing technologies and in new manufacturing concepts. There, industrial ecosystem consists of cloud computing, big data, advanced manufacturing systems. It is fully automatic. Numerical commands are numerical, totally interconnected system, machine-to-machine communication, and we have got zero fault, nearly zero fault or zero deviation actions, reactivity, traceability, predictability. These are the different actions. 3D printing, Logistics 4.0, nanotechnology, advanced materials, robots, autonomous vehicles, Internet of Things. These are all the different elements of the industrial ecosystem in 4.0. Now, so autonomous vehicle, now you know that the autonomous cars are there, but autonomous car is not the only thing. There are many autonomous things now. For example, in the mining operation inside the mines, in the agriculture field also autonomous vehicles are used, autonomous tractors are used, and so on. So this is the big industrial ecosystem has been developed, in which Internet of Things has also got a role to play. Now I will be talking to you about this is a machine operator. Now in this PPT, machine operator is giving the instruction to another robot there, and both of them digitally talking to each other. That is this robot does not understand the human voice, and this robot so this person does not understand how the robot will operate. There only digitally this person has got a console, and it has got a wearable devices. Through wearable devices, it will get the data from the robots, and they will interact together. This is known as the cobot. Co means co-worker in the machine along with the robot. They are machine operator plus plus robot. Both of them, they are working together. This is also one robot and another robot. This is a small robot. On the left hand side, we have got a small robot which is doing the precision machining there, or the machining or preparing some electronic circuit or preparing some Arduino board or some Raspberry Pi board and so on in the industry there. So both of them, these small robot and the big robot, they collaborate with each other. They coordinate with each other. They digitally talk to each other. Then there is another one, their machine operator, which also talk to each other. Now here I am showing you that how the robot is looking at the sorry, robot is looking at the laptop, and this person is giving the instruction through the laptop, and the robot is visualizing the what is on the desktop there. So robot is working just like child looks into a desktop on a laptop. Similarly, this and there. So both of them, they are operating, and this co-worker is giving the instruction to the robot there. So this robot is being trained, by this co-worker there, and it is trained to give the command to another robot to do precision machining and so on. So these systems have become reality in the industry 4.0. Now today we are going to discuss about the use of the AI and machine vision in the assembly line. And now AI and machine vision optimizes the number of units assembled per hour. That is, what is the purpose of using AI and the machine vision is to optimize the number of units assembled or number of units produced per hour, because there is no use of using AI or MB and putting so much investment if it does not improve the production or number of units produced per hour. We will be also discussing about the use of the predictive analytics and operational intelligence. In addition to that, enable predictive maintenance of the machines, which reduce the downtime drastically by predictive maintenance by the machine vision. In the reference one, that software it discussed there, which I told you about the Siemens Soundwave, Siemens Mindware. Yeah. So AI and machine vision in assembly lines, they optimizes the number of units produced per hour, number of semiconductor boards printed per hour. They are produced per hour. Number of pharmaceutical tablets are produced, which are autonomously produced in the assembly line. So assembly line has got large number of applications, and purpose of using AI and machine vision is to optimize the number of units produced, and the purpose of the predictive analytics and operational intelligence is that we do the operation intelligently as well as faster, and we are able to do predictive maintenance in advance there by proactively doing the maintenance using machine vision. Now I am showing you one diagram in which this is assembly line 1, line 2 and line 3 on the left. On the another side, I have got a line 1, line 2 and line 3. This is some factory 1, this is, let us say, the factory 2. Both the cameras and the information about the machine objects on in the assembly line at assembly line platform, there all the information is passed on to some S server. We will discuss about this concept a little bit later on there in the next one. And here for this you are using the AI. The concept is using deep learning, the training across the plants, and then this type of system has really been used there. The Relimetris company is a partner company with the Intel. That is being developed and designed in cooperation with the Intel. They are using the Intel processor in between there. And the purpose of the Relimetris system is to do small quality audit of the machines. Different machine objects which are doing the work, their quality audit is done. Machine objects, their quality is analyzed using this Relimetris systems which have been put to the use only in 2019 there. And Intel is very active in applying the AI and AI in their processors and using their processors. Now, let us start from this one. Machine vision for monitoring the function operations and the production stages. This work started from around 2016. That is, it is smart manufacturing, and this is the one of the reference which is there, in which how the machine vision monitor the functions and operations in the production. Machine vision means machines are being visualized using AI, and I have discussed this in my another book also. So the two references I have given, my embedded system book on system on chip, IoT, AI, and real-time system, 4th edition has already been printed this year. There. Now, machine vision system apply to object inspection. This is a 2015 paper where earlier machine vision an assembly line was visualized using mechanical, optical, and proximity sensors. So the application of machine vision concept in the assembly line was reported first in 2015 by one of the PhD thesis, PhD student at the Queen's University in London. There, and this thesis also talked about it, how the machine parts are inspected, and their deviations in the machine parts they are inspected, and whether they are within the physical limits or not. For example, suppose we are using a bearing, so bearing quality, bearing radius, for example, that ball bearing which you are using it, the radius of the balls and all this, whether it is within the fixed threshold limits and what are their deviations in that one. So this concept was used in this particular thesis and methods were given there. Machine vision system bearing deformation application. For example, a bearing might be deformed there. That is, suppose you got a ball bearing, and suppose it is put to some pressure in the at some assembling stage, that can get deformed, and so the data acquisition is done for visualizing from the bearing different image segments in this paper. And this paper was published as early as 2012, where the bearing defects were analyzed and their deformation were analyzed and quality were analyzed using the different image segments of a bearing, of a ball bearing. Machine vision system has been lately used from 2018 in using artificial neural network. AI methods use artificial neural network. I will explain what they are, say little bit in whatever time is being permitted. Their machine vision system detect the defective assembling process. In the assembly line, it is not that it is a mechanical system. Any time the part can come, power can play the role. Some component may play the role, and your defective assembly line functioning can be there. A process may go a little bit wrong there. So even human being do wrong. You must have heard the story of a doctor who operated left leg instead of right leg. There in the hospital there. So similarly, the similar thing can happen in assembly line, and so this has been worked out using artificial neural network in 2018. Now, another thing is that in 2018 itself, a flexible machine vision system was developed for small part inspection using support vector machine and using the artificial neural network method. Support vector machine is one of the AI method. Those who are computer students, they know what is support vector machine. They must have read about it. And similarly, those who are computer students, they know what is ANN there. So this work was also introduced in 2018. Taking inspiration from this work, we have taken the initiative to give a particular design approach there. So firstly, I will talk about the machine vision module, say hardware and the appropriate software for this. Now in the stage one, if you remember that I talked to you about the stage one, and stage one I talked to you about the devices network. Okay, and And also I talked to you about the stage 1 corresponding to machine object network or a sensor network, so on. So similarly, machine vision module at the stage 1, it consists of, in a linear assembly line, it consists of say 2 sections and it consists of 4 cameras. I will show you the diagram. Okay. Now you see that. Now in this 7 and the 8 stages, A1 to A8, these are the assembling stages. These are the assembly tables, okay? And this is the disassembler. Disassembler means that to remove the part if it is defective or some action is happening, then they remove it. There. For example, some part has reached at this table, but that part which has reached due to some vibration or something, that bottle, let us say, is not straight. So that bottle need to be removed from the line. There. So disassembler will do the job of removing the component for which have been not properly processed in the assembly line. There. So we have got a camera, let us say A, B, C, D on this side, let us say, and E, F, G, H on this line. This camera is this camera focusing on this one, this camera focusing on this second stage, this is for third stage, this is for fourth stage, and this camera is for fifth, sixth, seventh, and eighth and so on. So we have assumed that 8 stages and there are 8 cameras. And in the assembly line, the input is there from this direction and the output parts are going from this side. There. And if there is the purpose of these cameras is to visualize any malfunction or the correctness of the undergoing process, in the real time, so that if anything wrong goes, the disassembler function will activate and they will remove the component there. Okay. So this is the block diagram, and so in the machine vision, one of the element is camera, and LOC means local computing unit, okay, A means assembling unit, and D means the disassembler unit. Okay, so this is how it is going on there. So we have taken the example of 8, and there are 2 local computing unit. The purpose of local computing unit is to communicate the data from these images to the stage number 2 or say next stage. Now, so hardware will consist of assemblers and disassemblers. The disassembler, sometimes it means a robot which will remove the component from the assembly line there, and so local computing, say LOC, will communicate with the edge computing. So it is similar to a device is having a smart sensor, a temperature sensor is along with the microcontroller. Similarly, there is a local computing unit. There, with the camera, there is a local computing unit which will integrate the result from the 4 cameras and will send those result to the edge computing unit. There. Now, for linear assembly line, okay, controlling software will be at the edge computing unit, and it will find out whether it is inappropriate machine part, deformed part is there, defective part is there, low quality part is there, so that it will activate the disassembling at this stage. Disassembler may be a robotic arm or a pneumatic valve, or just a pushing lever for slipping or dropping the part of a collector. I have seen one machine being fabricated at Ambala, which was to remove the brown rice from the white rice. There, that is, as soon as the brown rice grain comes there, some air flow is there, some valve will blow the air, and that brown rice will blow off. And only white rice will pass through there and will go into sack of the white basmati rice bag. Now, machine vision for a semiconductor industry is widely used, and for pharmaceutical industry also it is. For semiconductor industry, we need 2-dimensional cameras or 3-dimensional cameras. We need for a semiconductor industry, this is the assembly unit, which is making some Raspberry Pi board automatically or some electronic circuits like for television automatically. there. So here, we have got a camera. These cameras are the rotating cameras, and this is the local computing unit. So rotating cameras are used in the two-dimensional or three-dimensional assembling units there, in which the functions are not linear as in the previous one there. Here, we are having a component in this direction also. We are having a component being soldered in this direction also. So soldering is in this direction as well as in this direction. Of course, soldering will be from the back side. I am just showing you the front side only. Soldering will be from the back side. But these cameras are sending the data through the local computing unit to the edge computing unit. Now we discuss about the edge computing unit in this case. Edge computing unit. Now edge means, as I told you earlier, the edge means nearer to the machines in industry. In IIoT, edge will mean that it is nearer to the machine. It is nearer to the data sources. It will acquire the data from different sources like cameras, machine objects. It will acquire the data for assembly functions. It will acquire the data for disassembly functions, and so on. So different sources of data which are there, machine objects, sensors, assembling and disassembly functions and operations, their data is sourced to the edge on the one side and communicate to the server using internet protocol on the another side. Okay, so communicate to the server using protocol for the IoT and for IoT and so on. Now, what is edge computing? Edge computing is a type of computing which modifies, assists the IoT computing applications data at the central enterprise or cloud or web server. Or you can say that it is a computing which is assisting the longer computing, larger data at the centralized unit. But before that, it is assisting that. It is the application and services they are executing at the edge itself. Those services which are required immediately, which, for example, in an assembly line, your disassembler need to be activated if some wrong part is there immediately. It does not have to wait for the latency to come from the instruction coming from the cloud. Computational latencies and thus time delay in actions are the small at the edges. Another example, for example, video analytics. Suppose you are having a video camera and analytics is to be done there. So in the centralized system, video analytics will take a long time. But if you are having the edge computing, doing the video analytics, then that will be faster. It will be at the much less this one. Suppose you are having a camera which gives you information that the machine part is not properly placed on the assembly line, then immediately the analytics will be done and action will be taken. Now this is a diagram where I am introducing little bit first the computing function blocks there. So the edge AI here, what it will be doing? It will be connecting to machine camera network. Machine vision cameras which are there, their network is there. For example, I was talking to you about the 8 camera. So ABCD, EFGH. It will be connecting to assembly lines there. Assembly line network A1 to A7. Another job is to configure and data acquisition from cameras, from assemblers and from disassemblers. There. Disassembler will need the data, how many parts which have been disassembled. Because it is going to reduce your UPH, unit produced per hour there. So number of time D becomes active. That is meaning that your UPH is going down, and purpose is to enhance the UPH by using the AI or some other technique there. Now I am having a edge AI computing. Means edge along with the artificial intelligence computing, AI inferencing, finding some inferences from AI. at the edge or object network. It will use data collection, application services, machine learning model algorithm, and using the TPU means tensor processing unit and TensorFlow Lite AI. There is a TensorFlow Lite algorithm for the tensor processing. Why do you need to process tensor? I will tell you in a little bit later on there. AI-based analytics for the control actions. AI-based analytics is done here for control actions, and it will send signals, it will send alerts and notification to sensing elements and to actuating units there. So the role of AI is application and services using the ML model algorithms and using the tensor processing unit and TensorFlow Lite software and AI-based analytics for control actions using signal alerts and notification to the sensing and the actuating unit. These are the different components at the AI. And it is connected to internet firewall and it is connected to S server. There is another unit. Now I am talking to you about the S server. And what is S server? This I will tell you a little bit later on there. Now, edge AI computing using artificial intelligence, machine learning, and deep learning algorithms, which are computationally intensive, means computing power required for machine learning algorithms is larger. And here, what is the meaning of machine? It is not the same machine as in the assembly line. It is the computing hardware and software which is producing a result from the instruction that is known as the machine. Your computing hardware and software is also producing, like an industry. It is giving results after processing of the instructions. That's why it is known as a machine learning. Now, machine learning is fast. Then I am using the edge AI units. It will run the AI algorithms. Its latencies are small. And AI algorithm enable real-time production decision by knowledge discovery for the actions using the machine vision hardware. Okay. Now I will come to this convolutional neural network concept there. Now let us say how human being recognized. We see your face, and as soon as we see your face, okay, I will recognize. As soon as I will see Dr. Vaibhav Neema, I will recognize that he is the Vaibhav Neema. There, how in my mind features of the face of Vaibhav Neema are stored in the memory. Not all pixels. All pixels are not stored. Only what are the features on the face of the Vaibhav Neema, they are stored so that next time I can recognize if the software is trained. That is, and after training, whatever software is built up, that is known as the model software. That model software will be trained, that is having large number of images in the database, and by looking at the feature map, by looking at the features, it will be able to identify what is the face or who is this person, So now let us look at the convolutional neural network. Convolutional neural network, what is doing? It is connecting the data points with the feature map. It is connecting for example, suppose this is the photograph. Then it is connecting to the features in that photograph. And from those features, the mapping is done. There. So basically, convolutional neural network is an algorithm which is generating the feature map in the output from the input data points. There. And feature map can give you the feature of machine objects, can give the features of assembly functions, can give the features of assembly operation, can give the features of color, position, distance, motion, segment-wise features. It can give you segment-wise features, and then it is used for controlling of the sensing and actuating elements at the assembler and the disassembler unit. So now what is the function of AI here? Function of AI is to take in the input, there generate a feature map in the output, that feature map, and find out what is the error in generation of the feature map, then assign the weight factor to different elements. Here we are having 25 into 1 matrix. Here I am having 800 to 800 matrix. Here I am having 65,000 data points there, and these data points are mapped to 25 into 1 elements in the feature matrix. Feature matrix is for every type of feature of machine objects, feature of assembly functions, feature of different operations, and then feature correspond to color, position, distance, motion, speed, segment-wise features, and so on. And they are used for controlling this feature there. So therefore, now let us try to understand what is the meaning of AI. AI means just like human being, identify a face. There, just like human being intelligently say by looking at the photograph, will be able to do the inferencing intelligently. They apply their intelligence. Of course, sometimes the judgment can be wrong, inferencing can be wrong. So similarly, AI technique is infers from the features. Feature matrix is generated from the input data points. There. Now here I am using the word tensor. A data point along two-dimensional space can be represented by a vector. A data point in two-dimensional space along xy axis can be represented by a vector from the origin. So any data point on a graph, for example, similarly, any pixel horizontal position and vertical position can be represented by a vector, which has got two components: horizontal component at the horizontal position component and vertical position component. Suppose I want to add color into it, there, then color will add another dimension to it there. So I will have now 3 dimensions there. 1 dimension representing color, 1 dimension representing horizontal position, 1 dimension representing vertical position. So therefore, the data points can be treated either as the vectors or as a tensor. An ensemble of vector gives you the tensors there. So you can say that the tensor is a vector with the 1 dimensional element being 0. So now it is up to us to, in my software, use what approach? Either doing tensor analysis, tensor processing unit, or do vector analysis using vector processing unit. Because vectors, 2 vectors combined together can correspond to a tensor. 2 vectors, 3 vectors combined together can correspond to a tensor, and a vector can correspond to 2 points there. So vector elements can always be represented the tensor element. Tensor element can always correspond to the vector element there. Now Intel is following the vector processing approach. ARM is following the tensor processing approach. So basically you can say that the modern ARM processors, they use the tensor processing unit, and Intel processors, they are relying on the vector processing. Even tensor operations, they are doing it through the vectors in the Intel processor. So difference between the latest ARM processor for the AI and latest ARM processor for AI by Intel, the difference is that Intel processor, they are using the open vector neural network instructions, open BNO instructions, and ARM is using the tensor flow instructions. Now, no, let me just 2 minutes. Now, please relook at this one. What is my aim? I have got large number of data points. I have taken the camera image of Dr. Rajkamal, let us say, or anyone, let us say. Professor XYZ, let us say, Professor XYZ, image is there of consisting of 6400,000 pixels there. It is my human mind, my neurons converted into features, and those features are stored in my mind. So therefore, next time, whenever another image having same features comes up, I am able to do the inferencing that he is Professor XYZ. These features are corresponding to machine objects and so on. So therefore, if I am able to generate, correctly the feature map from the input tensors, then I will be doing the AI operations. I will be doing the intelligently. I will be able to do the AI inferencing. Now, so therefore, this is a neural network. This neural network is starting from 800 to 864 neurons. They are changed to, I have got 400 to 400 neurons. These 400 neurons are again put together, 200, then 100, then 50 there. So I can have number of pooling layers to reduce the number of points for my convolutional integral or my convolution function. This is a convolution layer. Now in this convolution layer, output is obtained. Now output feature map may not be correct one. It may be having some errors. So different vec factor have to be applied and different biases to be applied. Bias means, addition. B is a vector and W is also a weight vector, which is applied to each element of the neural net, or that is each feature. And then again it is given as a feedback there. And then again convolution is done. This process is repeated till my feature map gives the correct inferencing. Or in other words, my neural network has been trained, my convolution integral has been trained, or my weight factors has been trained, or I am properly able to find out what are the weights and biases with respect to feature elements there, so that my input gives the correct AI inferencing of the data there. So basically, you can say is that convolution neural network, calculation. Basically, they are having pooling layer, activation layer, and the convolution layer. The purpose of activation is that apply and use some function so that weight factor does not become negative. Weight factor remain between 0 and 1. Because when the mathematical computations are done, your answer may come out to be negative. Suppose you have got a quadratic equation, your answer can be positive as well as negative. So activation mapping will ensure that your all weight vectors and all bias vectors, they are positive. And final aim is, so this algorithm, which is finding the model algorithm, which is using the correct value of W and B after the training, is known as a model algorithm. And this was the model algorithm which I was talking to you. I was talking to you about the machine learning model algorithm. Machine learning and deep learning, they differ in the sense only the number of layers which you are using there. In the case of machine learning algorithms, you are not using so many layers in between or so many neurons in between. You have got direct mapping. And in the case of deep learning, you have got the number of layers in between through which it is passing. My eye is also using the neurons to carry the features and then to recognize a particular face and do the AI inferencing. Suppose some needle is being pricked in your leg, okay, let us say in the left leg. Then immediately you will come to know that on the left leg some needle or some pin has been pricked there. Okay, your mind will infer automatically. So similarly, the machine vision concepts are being used from the camera. These are the images. They generate the feature map. From feature map, we are doing the analysis of the machine objects, assembly functions, and the operations. and from that it will find out what is the color, position, distance, motions, and other thing, and then controlling the sensing and actuating element at the assembler and disassemblers in the assembly unit. This is what is the important key process. So edge computing unit is a key unit in the whole machine vision based assembly line operations there. And CNN is being used. CNN is using TensorFlow instructions from left to right. TensorFlow instructions can be converted to the vector instruction. Intel processor use the vector operation. Okay, open VNano vector instructions for neural network. Intel has got a free software which is used in programming the Intel processor, and the ARM processor, they are programmed by the TensorFlow instructions there. Okay, so this I explained to you. Okay, now how this is done. This point I have also explained in my new book which has come recently. So this I explained, these points I explained to you. Now features after the machine vision images inferencing. Now CNN based AI inferencing will enable you notification for the maintenance of the assembly line. This will tell that the assembly line has, let us say, stuck somewhere. Assembly line is working with some faults. There some fault has been developed. Okay, so the assembly line maintenance, assembly line malfunctions, real-time actions and control signals, they are generated by the edge computing unit. So edge computing unit may not be same as we talked yesterday. Yesterday we talked about battery operated edge computing devices like ESP32, and they are the grandfather units compared to the edge computing unit which we talked about the ESP32 there. Now another concept is there about the edge server. Edge server means stage 3. If you remember the stage 3 in the application framework which I have given you. Here, what is the edge server? Edge server means this. You see that these are the different assembly lines, and these are the different assembly lines. This is factory 1, this is factory 2, and from the factory 1 and factory 2, all the things they are joined together, and they are then sending the data to the cloud there. So edge server is the one which is connected to cloud. Edge server will be connected to cloud in the one factory. Edge server will be another factory will also be connected to the cloud, so that the factory operation of the one unit can be synchronized with the another unit there. Suppose one unit is doing the packing and the another unit is doing the manufacturing. So packing unit has to work in the synchronization with the manufacturing unit. If the number of units manufactured per hour and number of units packed per hour, they are not same, they are not synchronized, then a company will pile up huge stack after the manufacturing. So we have come to now another thing is edge computing unit we have understood. That is edge computing unit will be doing connecting operation, configuration operations, and then will be doing the AI operation, data collection, application services, as well as the control operations, sending the notification to sensing unit and acting unit as per the output in AI inferencing from the convolutional neural network unit, and this data will be going to the edge server. Now we come to stage 3. Stage 3 we are having edge server and the cloud services there. Now IIT technology uses edge server and as well as the web cloud services. Edge server means to connect different edge AI units, because as I told you earlier, and as you already know, that edge AI computing unit cannot handle very big load of data. So therefore you will have another edge server which will be combining all the data, taking the data from all, but edge server will be connecting to cloud and the other platforms. Now let us come to cloud services now. In the cloud services, what we are doing it is that we are having database. This is the connectivity of the edge AI unit. They are connected to edge server. They are connected to database firewall, internet firewall, and then here I am having the cloud services. What are the cloud services? One of the cloud services will be to prepare databases. Databases, because assembly line operations data and assembly line malfunctioning data, all these have to be stored for analysis further, so that you can improve the operational data using the operational intelligence, that is using AI for the operations to maximize the UPH with minimum rejection of the mechanical parts. So databases are must, where databases will have the data of the assembly line functions. Their database will also have the data of the time taken from one assembly stage to another stage, so that whether there is any friction in developing in the assembly function, because edge unit was working only in the real time operation, but detailed data analysis will tell me that how to improve the operations and functions in the assembly line. So databases, cloud services, one of the thing is databases. Cloud services will also having the applications. There are different applications. Cloud services will also have the unit to generate the DNN models. Now remember one thing, I talked to you that the edge unit will store the ML model algorithms. So model algorithms are being executed at the edge unit, but model algorithms, they are created at the cloud service. They are created here, because here computing power is practically infinite. It can take a long time. Cloud services will do descriptive analysis, prescriptive analysis, and predictive analytics. There, three types of analytics are there. One is the descriptive analytics, one is the prescriptive analytics, and one is the predictive analytics. Then cloud services are also used in assembly line operations for the operational intelligence, predictive line maintenance, and optimizing for maximizing UPH with the minimum rejection of the parts there. So this is the list, okay? There. Cloud services deploy databases, software, etc. This I have already told you. There, software at the cloud interpret the using the advanced analytic descriptive methods for getting the data insight into machine vision. That is, in descriptive analytics, give me the insight. Suppose I have got a sales figure of the company with respect at different years. Suppose I have got a investment data of the debt. Suppose I have got the factory closure data of the different years and so on. So that data insights give me the insight of the functioning of a company. How the sales of the company are there, how the production of the company is there, how much investment in the companies are there, how many months where sales were low, and so on. So descriptive analysis is the first element to give me a data insight into the machine vision data from the different cameras which have been received through the plethora of the edge computing units and through the edge server to the cloud services there. So and optimizing the production. And the analytic three phases will enable that driving the new phase and will enable to provide the operational intelligence. Now, descriptive analysis enable to give you the additional value by looking at the past performance. Using the report card of your child of the previous years, you can take the appropriate decisions what is to be done next. It will give you the insight of the child functioning there. By suppose BTech final year student, you see the data of the first year, second year, third year there. For the past performance, you can guess that how student will do in the next year. Descriptive analysis means finding aggregate values, frequency of occurrence, their mean values, variances in the values, grouping of the values using selected properties and applying those properties. They are evaluate the performance from analyzing the historical data in detail. The descriptive analysis plays very important role, and that is to be done at the cloud only. That is not done at the edge computing unit because of the limitation of the computation there. Descriptive analytics, from descriptive analysis, you can find the reasons and performance or successes or failures in the past there. So descriptive analysis is important to get the full data insight. Detailed data analysis will give you that. Yeah. Now, prescriptive analytics will enable derivation of the additional actions and undertake better decisions for new options. Prescriptive means that the doctor after getting the insight of your data from your medical reports, your pathology lab reports and so on, doctor will give the prescription. So similarly, prescriptive analytics gives the prescription. It will give you the rules. There, prescriptive analysis can suggest what to be done for maximizing the output. It will give you the best course of action which can be taken. So prescriptive analytics is also equally important, and prescriptive analytics is also done not at the edge computing level, at the stage 2 level, but at the stage 4 level. Now, now come to predictive analytics. Predictive analytics is doing the advanced analytics. There, it will enable extraction of new phase and new knowledge, and then predict and forecast. Advanced analytics, predictive analytics will be predicting for the future from the previous data. There, predictive analytics will predict anomalous characteristic from the insight of data. It will tell the need of a proactive maintenance. For example, your data insight shows that this assembly line from stage number 1 to stage number 2 is showing the variation in the timings of the movement of the object. Movement of the object from assembly stage 1 to assembly stage 2 is slowing down. Then predictive analytics will tell that there is a need for maintenance of the line. There is a need to put oil there. Suppose in an automobile, suppose you are having a data that it is not giving you proper, it is consuming more petrol now compared to what it was consuming per kilometer earlier there. So it will give you the need for maintenance there, need for oiling and the other thing. So predictive analytics answer the question what will happen in future from the insight of the past data. Prescriptive analysis will write a prescription like a doctor. Predictive analytics will predict that what could be needed in the future. There. Suppose prescription is that let us say prescription is that, for example, BP remaining high and so on. From that, doctor can also forecast by looking into other data that what is to be done. Now, one of the important thing is that in the assembly line applications is that analytics will provide data insight and operational intelligence. Operational intelligence is a term, okay, in which apply to the use of intelligence automatically by the AI software for the operations in the assembly line or for operations in the production line. Operational intelligence enable the productive maintenance of the parts, optimize the functions and processes for maximizing the UPH. Operational intelligence uses AI and analyze data of the machine vision modules there and assembly functions and operational units there. your machine vision module, how they are operating, how they are analyzing, and assembly functions and operational units. This from this data operational intelligence is gathered for optimizing the output. Yeah. Now we will now I will discuss about what are the recent implementation. One of the implementation I have already shown you has been done by Realmetrics in partnership with Intel. Now I will talk to you about recent implementation and the future directions there. Now one is that the Siemens. Siemens had developed a software, and that software they have put it on the AWS. So therefore you don't have to spend money on the MindSphere software, but you have to spend money for the cost of using the AWS EC2 or AWS S3 Amazon Web Service. You need the money for it. It will implement AI and IIoT concept based design approach. I have told you about the different modules, databases, descriptive, predictive analytics, etc. Those modules are available in the MindSphere software, which have been given by this thing. Moreover, another thing is that in the computer science, whatever software is there, okay, many times, okay, you don't keep it proprietary software, and you give it free. So later on, you buy the hardware, associated hardware from the company. You will buy from the Siemens company the corresponding hardware for machine vision and for edge computing units and others, and they will be buying the robots from Siemens company or from ABB Asian Brownberry company. They will be buying the robots so that those robots can function as a disassembler and can also use the IIoT concept, that is operational intelligence concept there. So operational intelligence will be used for disassembling robots in the assembly line. That hardware you have to buy from Siemens or from any other company. It is an open source operating system at the AWS cloud system. MindSphere services collect and transfer manufacturing plant flow data. It includes compute, analytics, IoT, machine learning, and the visualization methods. It gives you the cloud services which focus on achieving manufacturing functions with high operational efficiencies. So we have to learn about how to use the AWS cloud and how to use the MindSphere there. And then if you know how to use it, then buy the appropriate hardware and then use that hardware and streamline your assembly line operations for any industry, for example, manufacturing industry. There. MindSphere services focus on achieving manufacturing function with a high operational efficiency. This is what Siemens is claiming. Now there is another company, Advantage company. It is also the partnership company with Intel. It manufactures the industrial personal computers there. Its details are given at the reference 2, which I have given earlier there. The company offers the hardware, okay, for edge computing unit, for the edge servers, and for computing systems. And this company is using A9 processor and i10 processor in the industrial PCs. i10 is in the market now. This year i10 is in the market. Last year i9 was in the market. And now earlier it was i7, then i5, and then i9, and so on there. So the Advantage is using industrial PCs, and it is offering that edge computing hardware and edge servers and so on. Now Advantage is also offering the IET-DAVV software, that machine vision software for the machine objects and for machine operations for the given hardware platform. IET-DAVV is an integrated software development suite by the Advantage company. It consists of Vision DAVV for the task flow of the machine vision applications. Task flow means how the different tasks is done in the sequences. It consists of data acquisition unit, which connect the data acquisition unit, conditional monitoring unit, and control and sensory unit. AI, Navy will perform deep learning based image analysis. For example, deep learning based analysis, I have shown you by the convolution neural network. It have HMI interface. Then it has got the soft motion vision. That is to visualize the motion of the machine objects from one assembly stage to another assembly stage. There, advantage modifies advantage operation different from the mind sphere approach. Mind sphere approach is to offer you a software at the cloud. The advantage offer is to offer you the edge computing unit and the edge servers, in addition to use of the cloud data at this one there. So this is another approach, and that is another approach. In the advantage approach, you are using the Intel softwares and Intel open vector neural network processing units there. While in the case of the other approach is TensorFlow units and so on. Now, the proposed design in this paper is that what our design differ is that we are proposing the use of CNN based machine vision in the assembly line real-time functions, and so that we get a better analytics and we get a better operational intelligence cloud services there. Now, future directions can be that applications of the proposed design can be in the electronic manufacturing unit, semi-unitary unit, or packing unit, beverage unit, and the pharmaceutical industry unit. I don't have a data corresponding to, the capability to acquire the data presently, and don't have cameras and as well as for the machine vision and also the industrial PC and the other operations there. So presently our work is limited. Our work only gives a design approach which will be using the industrial IoT as well as the AI. So I finish it. There we have learned, we can summarize that we have seen a design approach in which we can use CNN based machine vision or the machine objects, assembly line functions and operations. We have seen what are the different stages in the assembly line operations using the machine vision there. Stage 1 is MB module hardware for linear assembly line. Stage 2 is the edge computing unit software. Stage 3 converts to edge server, and edge 4 converts to the cloud server. We have also seen that the recent implementation from Siemens, we have also seen in the beginning of the Realmetrics implementation for using edge server. We have seen that advantage experience suited by what they are doing it and what are their capabilities. Future directions, we need actual insight using the experimental results in the semi-unitary unit or in the assembly unit. So with this, I finish my talk there, and thank you very much for this one.
Okay.
Now we can take up the questions in the remaining period, and I have finished early, but I think this is too much for the audience at present and for today. But let us have interesting questions from the audience so that we can get more clarity what we are doing.
Okay. Audience, if you have any question, you can ask. You can directly ask to the speaker, or
you directly ask them.
You can ask through this chat board. Sir, a term fog computing is also now used by so many companies. So, what this fog means? It's an intermediate state of cloud and this edge computing.
Actually, fog computing is something intermediate between the edge computing unit and the edge server. I have told you about the edge server. It is Cisco is using the fog computing approach.
Okay.
Cisco had developed a fog computing approach where different edge units and different devices network they are computed there. So fog computing approach is now it is up to you that you have the several edge computing unit. Then you do the fog computing, and fog computing data you send it to some edge server, and then edge server data you send it to that. So instead of using edge server, the Cisco suggests that we should use the fog computing.
Okay, sir, I have received one question. The question is major difference between edge server and a normal web server.
Okay. Okay. Edge server will collect the data only from edge computing unit, and or it will collect the data from different industrial PCs there. So that data before going to cloud, it will be integrated together because a company, a industrial plant has got the number of assembly lines. For example, let us say a scooter plant. A scooter plant is having number of assembly lines. Similarly, for example, a semiconductor electronic board manufacturing company has got number of assembly lines. Similarly, let us say a pharmaceutical industry has got number of assembly lines. There, a company like Amul has got number of assembly lines for for filling up milk and filling up curd and all those things. So, as server will be combining those data from different edge units before sending it to cloud.
Sir, one more question from my side. Sir, if this edge computing is means efficient to is a high processing unit, if we have efficiency is very high, so in future it may be possible that we eliminate this cloud computing factors from this IoT or AI perspectives.
No, I will tell you why. I'll tell you why. Actually the putting the data for a long time, storing data long time is a necessity. Yeah. Okay. Suppose a company is doing assembly line operation and so on, it want to develop better operational intelligence there in future. So it has to put the data somewhere else. There. Okay. Moreover, I have told you one very important point. Edge computing unit is using only model algorithm. Okay. But the model will be developed in a higher computing unit which is at the cloud.
Okay. So once the model is developed and matured, can we transfer that model to that edge computing?
Yeah, this is what it done. So the model at the edge computing unit, actually nowadays another concept has come up recently in 2018. It has been developed and it is becoming popular. It is tiny ML. Okay. That is machine learning model. It trained at the server. Mm-hmm. There, it is trained on a neural computing machines. There, the big machines which are available, must be knowing GPU are available from NVIDIA and so on there. And nowadays people think that 10 to the power 17 instruction per second is also slow there. Presently, as I have told you that iPhone 11 which is available, it is with the A11 server. Processing speed is 10 to the power 17 instructions per second. There, so slowly the processing speed is increasing. Yes. But in the edge computing area, there it will depend upon what is the scale of operation. It will depend. Suppose you are a big industry, then you will need an industrial PC with i10. Yes. Or if you are having the small industry, it may work with the i3 itself also. And I was talking to you about the tiny ML. Tiny ML is another concept that develop machine learning algorithm at the server, transfer it there. Even Arduino board is available now. This year, Arduino board with tiny ML is available.
Okay.
Arduino board. So therefore, machine learning algorithm will develop here. And I will tell you one very interesting application which have been developed at the Michigan University in 2018. That application is that you have a temperature sensor. Temperature sensor is built in. Wireless harvester is also built in the chip there. And microcontroller is also built in the chip. That is the temperature sensor. That is having AI inside it and AI algorithm inside it. It has got a wireless harvester and the microcontroller inside it there. And now it will analyze even smoke also. Okay. There, because suppose you are having room temperature sensor, then temperature, the rate of change of temperature with time is different. And the second derivative or rate of change of time is different. And suppose there is a fire in the room, then the first derivative and second derivative both will be high.
Okay.
So therefore, using artificial intelligence software, you are able to interpret not only the temperature value, but you are able to interpret that there is a smoke at the that much distance. Okay. Yeah. So in the output, you will get a smoke at this much distance. You will also get an alarm that there is a fire, and then you also get a temperature data. So you have got a temperature sensor. With the AI, you don't need a smoke detector. You don't need a fire alarm or the fire sensor. And the same chip, without battery, it will work. The Mission University developed this. They have got a low power embedded unit. They are in the Mission University. Yeah. Now, another interesting development I am going to tell you is that in 2018, in the Stanford, etc., they developed the robots which can emulate the emotions there, which can imitate the emulations there. So, artificial intelligence, artificial neural network, they are used for detection the faces. Then artificial intelligence, the neural network, they are used for detecting emotions. Now, because computation speed has become faster, 10 to the power 15 with the NVIDIA processor and so on there. So they are able to detect the emotions. Now, if those emotions are simulated or they are imitated in a robot, that robot will start talking. And this is how the robots are able to give interview now. In 2019, the Sophia was developed, and Sophia is able to read the news and take the interview and work like an anchor. You can maybe better anchor like Anjana, better than Anjana Kashyap, at least it will work there. So a lot of development is taking place in the AI, and AI is going everywhere, I think.
So means from your perspective, in future we will have some Arduino board with the inbuilt MI algorithm itself. That is known as a.
No, it is the market. The market. We will send you the details.
Okay, sir. Okay.
We have purchased in our laboratory, okay. and day before yesterday I got an Arduino board with the machine vision also with the camera interface.
Okay.
Normally Raspberry Pi is used. Normally, yes, Raspberry Pi is used for with the camera there. But one Arduino with the Arduino board, you can also attach a neural stick. Intel has prepared a neural network stick, okay, which you can put it to Raspberry Pi port. So you have so therefore now Arduino also people have also put the Intel neural stick which can do the neural network operation along with that. So such are the developments which are coming in the 2020. Just like COVID is a development, similarly, on the other side, new developments are coming in the other areas to benefit the mankind. Another questions?
Any question from this audience side? So shall we close this session, sir?
Yeah, and I have given I have given the PPTs to you. You can circulate those PPTs to the members who are participating in the FDP program, so that they benefit, okay, yes, and they are able to give the test question. I think I have to give a test question also to you.
Yes, sir. You have to give the test question. You have to appear for the test on last day of this FDP program.
Okay, so thank you for the opportunity and thank you very much for the interaction.
Okay, sir. Thank you, sir. It is our pleasure that you accepted our invitation and you give us so nice talk for this continuous 2 sessions. It's very difficult to speak the two sessions continuously. Thank you very much. Thank you, sir. Okay, participant, if you have any question, you can send with a mail. And next session will start with this 2 p.m. That will be some experimental or some demo kind of session. So that session will also be maybe the interested session for you. So we'll have a break for this half an hour and then we'll again rejoin at 2 p.m. Okay, thank you for participating.